So good morning, everybody. I hope you have as much fun and delight as I have on this conference. So I think the last day, yesterday, was grand. There was some really cool science being presented. There was a lot of fun parts also. And if you enjoyed as much as I do, then I guess you're having a good time. A few announcements in advance. And the very first is Cecilia in the room already? Yes. So the postdoctoral network of the IRE thesis would want to introduce again their endeavor. So Cecilia, just for 1 minute, please.
Thank you, Christoph, and welcome back today. For those of you who are new here, my name is Cecilia Fries, and I'm here representing the IRI thesis Postdoc and Young Researchers Network. And we are here to ask for your help with a survey, a small study we are doing on the challenges that we face as researchers when we work and transdisciplinarily around questions of scale. So both the challenges we face when we want to integrate and exchange, when we come with different backgrounds, but also around the meaning of scale and what it is. And we want to thank all of you who participated already yesterday and the days before the conference, and really encourage the rest of you to join. It's part of a larger study where we're going to do an expert elicitation thing afterwards. And as a small enticement, we are raffling around 2 books that you can win if you participate in the survey by the end of the treasure quest today, I think. Then we will draw lots. You have a small flyer in your conference bag. There's both a QR code you can use on your phone, and there's a link. And we are standing in the foyer as well with 3 computers. You can just come down there, talk to us, join us. And also, because we had a few questions yesterday, I just want to emphasize that there's no such thing as wrong answers or stupid answers. We are really interested in your opinions on this topic. But come and find us. We are wearing small badges with bridges on them, so you can chat with us if you have any questions. And thanks again.
Thank you, Cecilia. I really think it's great what you're doing, and I hope this is going to end up as a really nice publication in the end. I should say apologies from the president, Sabine Kunz. She just sent me an SMS that she has an urgent duty at the Charité. Well, not for medical treatment, but in her role as president of Humboldt-Universität. But she still says that she would rush to join Johan Rockström's lecture in the next minutes or so. So we hope she's coming in late. Yeah. So greetings from the president again to the second day of the Kosmos conference. Also, you may have realized that other than what we expect at a sustainability conference, there has been some plastic yesterday in the morning at the coffee break, and there has been actually some meat with the food in the afternoon yesterday. We apologize for both of this, because this was not what we wanted. We've been discussing with the caterer. The caterer also apologizes, and they told me that they will do their best that they improve today. So, and I think that since they are doing a really cool job, I think we just support them on that. But it's walk your talk, so we should live up to what we are doing research upon. Good. Then you know that today there is a lot of crazy formats up here, the bar camp and the marketplace, just following the lecture by Johan Rockström. We have the treasure quest second part. Join in. Don't lose the interest, hopefully, and communicate your treasures then in the afternoon here in the plenary. That'd be great if that'd be really something that is, I think, a fun part. We should really make this a success. And then, since they're then citizens of Berlin coming to join you, you should be hopefully available for them in the entrance hall, accompanied again, hopefully by vegetarian food and good drinks, so you can discuss the SDGs with citizens at the Citizen Sciences speed dating just before we proceed to the public debate tonight at 7 o'clock and the farewell gathering and DJ party starting at 9 o'clock tonight. So that's the program. I skipped the expert forums in this small schedule. The expert forums are after lunch break, 2 sessions. And I think you have realized yesterday that there's some really cool science being presented in the expert forums. So go there, enjoy it, and have a great day today. we have prepared a statement, a communiqué over the last 2 days as the science board. And if you read it carefully, you will see that we have tried to integrate specific items that have come from Beatrice Krona, Eric Lombard, and Anne-Christine Mittwoch's talks during the last 1.5 days. We would want to issue this as a press statement, as a press release via the university. This is well organized with the press office of Humboldt-Universität zu Berlin, and you're very much welcome to sign this petition, this statement. And it's downstairs at the entrance, at the registration desk, where you find a printout and lists to sign in. You also have a PDF attached to an email that I sent out this morning to the list of participants that I am aware of. And finally, if you sent us an email saying that you would want to be one of the persons that have signed this petition or this communiqué, this is also welcome and fully okay. So it'd be great if we make this a success as well. Now let's, with a little bit of delay, start with today's program. And it's a real pleasure to have Johan Rockström here on the conference at Humboldt-Universität zu Berlin. And it's a bit difficult to introduce Johan Rockström. I think you all know him quite well. Nonetheless, let me find a few words. Johan has an MSc in agricultural sciences from Uppsala University in Sweden. He also has a diploma in agriculture from the Grande École Institut National Agronomique, Paris-Grignon. So he has a French degree as well. Goes further with this. Actually, in 1997, he received his PhD in natural resources management from the Institute of System Ecology at Stockholm University. He has been a regional advisor for some years in East Africa, and then has been senior lecturer and regional research coordinator at the UNESCO Institute for Hydrological Education in Delft in the Netherlands, then became director of Stockholm Environment Institute in Sweden, became director 2007, in addition then to his prior position as director of the Stockholm Resilience Center at Stockholm University in Sweden. Since 2018, he is the chief scientist of Conversation International, and also since 2018, the director of the Potsdam Institute for Climate Impact Research here in the vicinity of Berlin. Johan Rockström has been listed as the top 10 Sweden's most influential person on the environment in all the years from 2010 to 2014. Actually, 2012 and 13, he was leading the list. He has received the Marsh Award for Climate Change Research of the British Ecological Society, the Environmental Award in Germany, the Deutsche Umweltpreis, which is the highest environmental prize that you can receive in Germany. He has the French distinction of Knight of the Legion of Honor, the Ehrenlegion, and he is a laureate of the Hillary Institute of International Leadership, which he received in 2017. So we are so grateful that Johan, you as a distinguished scholar on the sustainability sciences and planetary global boundaries, that you're joining us on this conference, and we welcome you on stage, and we look forward to your contribution.
Thanks, Christoph, and good morning, everyone. I should say, though, that what makes me most proud is to have the honor of giving a talk at the Humboldt-University at this Kosmos conference at the 150-year celebration of whom I would call the world's first Earth system scientist, Alexander von Humboldt. So as a professor in Earth system science, I'd feel at home, and I think this is really significant. What I'd like to do is, over the next 40 minutes, give you scientific justification for a new definition of sustainable development. I'm sure that Alexander von Humboldt would have been able to do it already in the 1780s, that now we're talking about prosperity and equity within a stable and resilient Earth system, and that is the pathway for the future for humanity. And that this will take me to the point where I promise you I'll try to answer this question: is sustainable development within planetary boundaries a utopia or a panacea? Now, the drama of this lecture can be summarized in actually just a visual. And of course, this is something that has been on our eyes and lips for quite some time now with the 50-year celebration of the Apollo 11 mission. This is actually the Earthrise picture taken at the Apollo 8 mission. Every astronaut who has been giving testimony to having seen this in real life says it's a reconfiguration of the brain. You simply reconnect to the planet, this little beautiful blue marble out there in the margins of the universe. The problem is that we cannot all be astronauts, so we cannot wait for the world to understand the preciousness of the Earth system for our own future by taking us all to space, even though Richard Branson and a few others think that that might be the path. Now, science is a proxy for this. Science tries to tell the evidence-based story of what astronauts have been seeing when they photo the Earth rise. And the drama is very significant. We have all the evidence, I would argue with zero uncertainty today, that it's in the last 50 years that we have changed conditions on Earth as they have prevailed over the last 10,000 years. That is an unequivocal statement. What is perhaps a little bit more related with uncertainty, but I would argue increasingly with high precision, is the more dramatic following, that what happens in the next 50 years will determine the outcome for the coming 10,000 years. Now, if this is correct, if the evidence which is pointing in this direction is correct, it means that we are now standing on the knife's edge. Most of us, well, actually no, I'm just looking at myself here, have been part of the journey into the point where we are. So I'm the first to put up my hand and give my testimony. I am one of the culpable. I admit that I've been part of the journey, the great acceleration that took us unsustainably to the pressures on the Earth system that is putting ourselves at risk. If I'm in good health, and most of you in the room, we will be actually part of the large part of the journey out of this point. So it's for this generation right now to stand up and take responsibility for the transformation towards an equitable and prosperous future for humanity on Earth. This is the moment. This is why youth in the world have all the reasons for concern. It's not only about the frequency and evidence of extreme events, which I won't list here because you know them so well. It's not only that we've reached 1.1 degrees Celsius warming, the highest temperature on Earth since the last ice age. We are bumping the ceiling of the stability of the Holocene. In the last 5 years, we have the 4 highest temperatures ever recorded on planet Earth. But it's not only this, it's actually that we're starting to understand the changes. You may know that at Yale University, Tony Lizerovitz and his team does opinion polls every year and has been doing that for 10 years. Below the media noise that gives this impression that even in the US, that this polarization on climate change, year after year, roughly 70% of US citizens are worried about climate change, trust climate science, and want climate action. This applies for all the European countries, it applies for China, it applies for India. This is very reassuring. So when youth steps up with the Fridays for the Future, with Berlin being the ground zero in the world, I would argue. Yesterday I had the privilege to have a long phone call with Louise Neubauer. I think you should be so proud of what you have in youth movement here in Germany, preparing for the 20th of September, which will be the grand planetary endeavor for the youth movement in its next step in the run-up to the Antonio Guterres Climate Summit in a few weeks' time. Her message is the following: we might be hitting a glass ceiling of enthusiasm among the youth because the youth are demonstrating and they don't really see big impacts. What are the results? Now is perhaps the time for what has already happened but could actually be an argument to ramp up even further, the science for the future. Because the beauty of the youth movement is in fact that they stand with 2 cards that nobody else can play in any negotiation. They have the future, but they have truth. Because they only say one thing: we want you to implement what science says, and science has officially expressed their support for the youth movement. So something is happening, business is moving. You've all seen this graph, I'm sure. This is the risk report from the World Economic Forum. You have on the y-axis the perceived from business leaders impact on their business, on the x-axis the likelihood of this impacting, and up at this right-hand corner you have the high impact, high likelihood events that could risk business and economy. And as we know, now it is climate change, biodiversity loss, water scarcity. Everything that has to do with the Earth system is now at the upper right-hand corner of business perceptions on risk. So we're seeing a trend line here, and science is corroborating this. I would argue that these are the two most important scientific reports we today have on the table: the IPCC 1.5 report, which came last year, and the IPBS, the Intergovernmental Platform on Biodiversity and Ecosystem Services, the first, or the second actually, global assessment on biodiversity and ecosystem services and their role for human well-being. The drama in this latter report, you all know. We are at a 60% loss of species on Earth, according to the latest Living Planet report. And according to the IPBS, we are threatening 1 million species on Earth of the 8 million known species. 30% of the species, by the way, are hosted in the Amazon, which is now on fire, and largely parts of it on fire because of President Bolsonaro's inability to take responsibility for one of the Earth system regulating biomes on the planet. This is work in progress. This is for a paper that we hope will be published in just 2 weeks' time in the Climate Summit. This is what science has been communicating over the past 20 years. What you see here is the 4 latest IPCC assessments. So the TAR is the third assessment. Then you have the AR4 in 2009, the AR5 in 2013, and the 2018 SR 1.5. You've seen these red embers diagrams. You have temperature, average temperature on Earth on the y-axis. The redder, the higher is the evidence base on risk that we risk at those temperatures to tip the systems across thresholds. You see on the furthest left unique and threatened systems like ecosystem collapse. You see in the middle extreme events. And then the one that gives the biggest worry on the furthest right, what the IPCC has called the large-scale discontinuities. You could call it crossing tipping points. What you see here is very dramatic. Look at the red shading in the furthest right from 2001 to 2018 in terms of how the risk of disastrous change is going down. In 2001, we thought that the risk was at roughly 4 to 5 degrees Celsius warming. Today, the risk level goes down to 2-3 degrees Celsius warming. This is what happens. The more we learn, the more reason for concern we have. So it's a very clear message today that when we in Paris had 200 nations signing on to the Paris Agreement, the numbers staying well below 2 and aiming for 1.5 were not some kind of arbitrary numbers related to what the economy can deal with in terms of an applied discount rate or what we can, so to say, adapt to. Oh no, these are biophysically hardwired numbers. These are numbers that indicate that if we go beyond 1.5, we start really triggering irreversible change. If we go beyond 2, we again risk even more irreversible change. The land report that came just a few weeks ago supports this even further, showing the risks we have from water scarcity to the left to food instabilities, going down in temperature. So the deep red here across the lines is between 2 and 3 degrees Celsius warming for impacts on land related to climate change that will impact world development and sustainable development goals in a very dramatic way. So there are some insights that have been advancing over the last 30 years that takes us, in my mind, to a new paradigm for world development on Earth. Let me just share you quickly the 3 insights that brought us to the planetary boundaries, which I think should guide, whether you take a planetary boundary framework or whether you take another one, which should guide our future on Earth. The first one, of course, is that science welcomes humanity to the Anthropocene. As you may know, the Anthropocene Working Group has now decided, voted formally, to define that we have now reached a new geological epoch. So this is now formalized and set. The Anthropocene, as we all know, is not some kind of hypothesis. It's based on the observations of the hockey stick patterns over the last 150 years. So on the x-axis here, you have from 1750 till today, and the hockey stick patterns is just to show you that it doesn't matter whatever parameter you pick. On the green side are the pressures on the Earth system from deforestation, carbon dioxide emissions, nitrous oxide, eutrophication, overfishing, biodiversity loss. They have the same pattern. Up until a certain point, we have limited impact on the Earth system, and then bang, off we go in the mid-1950s, the point of the great acceleration. But there is a further drama here. And the further drama looks as follows. Here I take the same curves. You have the time axis here from 1750 until today, And I'll just flip them through how they look like. Here you have the northern hemisphere temperature, population growth, carbon dioxide concentrations. Here you have deforestation following the same curve, GDP growth. It's a mix of social, ecological parameters. And you see the trend line. They all look the same. They bend in 1950, fish exploitation, ozone depletion. And the key insight here is that, yes, we entered the Anthropocene in the 1950s. But it seems, according to the latest science, that the Earth system is so resilient that even through unsustainable exponential rise in pressures, that delivers in a phenomenal way to human well-being. I mean, I have full respect for the late and dear colleague of mine and friend, Professor Hans Rosling, who always made the point that, look here, the world has become so much better. We've moved from 3 billion people in 1950 to 6-7 billion people today, and we've never lived so long, and we've never had such good lives in terms of access to food and fundamental components of human well-being. But it seems increasingly like this happened entirely at the expense of the planet, and moreover that the planet was able to deliver without sending its own invoices back to the economy. There was enough redundant forests out there. There was enough redundant species for ecological functions. There was enough redundant fish. The atmosphere could absorb enough greenhouse gases. The ice sheets were so stable, even if they started melting, they still had enough albedo reflective capacity. The Earth system was so resilient. Increasingly, and this is an hypothesis, I would argue that from 1990 onwards, we start seeing the scientific evidence that we may have reached what I would call now the saturation point. That we hit the ceiling of the point where the Earth system starts losing resilience. And there's so much ample evidence around this, and I won't go through the list here, but we have the classic, the collapse of the codfishes in Newfoundland, tipping points of freshwater systems, the Baltic Sea tips over, we pass 350 ppm, the Arctic sea ice accelerates, we have the ozone, stratospheric ozone layer reaching a point of a fierce emergency, what takes us to the Montreal Protocol. It seems like the last 25 years is the period of saturation. Now, I mention this particularly because evidence also shows very clearly that the timeline between science being established and really unequivocally convincing and action is roughly 25 years. That's very depressing, by the way. But it seems to have been the same case when it comes to links between smoking and cancer, between acid rain and tree death, between freon and chlorofluorocarbons and stratospheric ozone depletion. This is a report by United Nations Environment Programme, already 12, 13 years back. The title being How Late Response to Early Warnings. What if this is almost like a coded genetic inability of humanity, that we are not able to react faster than a 25-year lag time? Well, if you count 25 years from 1990, where do you come? 2015. What happened in 2015? The Paris Agreement. What happened in 2015? We adopted the Sustainable Development Goals, the world's first roadmap for a people-planet agenda for humanity. What if we have turned a corner? What if we have, as Professor Carl Folke at the Stockholm Resilience Center says, reached a new renaissance point that is now inevitable? We are in a kind of in an Alexander von Humboldt way, having a new paradigm of understanding that the Earth system is now a precious necessity for our pathways forward. I would argue this is a plausible hypothesis. I would challenge us as scientists, perhaps the Humboldt-Universität, to really put some evidence behind this. The second piece of evidence is, well, if we're putting all this pressure, are we leaving the Garden of Eden? Are we tipping the planet away from the point where it can support humanity? I would argue that we today have a lot of evidence in support to precisely define what's the desired state of the planet. You've seen this Milankovitch curves of the 1.1 million years of 110,000 years cycling between ice age, 100,000 years, and interglacial. We've had 6 to 8 such cycles over the last 1.1 million years, forced by orbital forcing each time. So these are natural variations. This is the last cycle from the Eemian 120,000 years back up until the Holocene today. If we kind of zoom into that last cycle, it looks as follows. This is from the northern hemisphere. This is data from Greenland. This on the y-axis is temperature variability. And over the last 100,000 years, picking out that 100,000 years because it's a good choice, because we've been modern humans on Earth roughly 100,000 years. So we've had, let's say, the same ability mentally and physically to develop civilizations as we know it. And you can just look at the graph to see that it was a bumpy ride indeed. You know, we had tremendous fluctuations of temperature and living conditions on Earth during this time. The temperatures could go up and down 10 degrees Celsius on average over a decade. We had a very rough time. We were hunters and gatherers, a few million people struggling to survive until we leave the last ice age and enter the small period you have here in the red circle, this extraordinarily stable Holocene period. You all know as well that we barely enter this, and what do? We do the most important invention of all. We leave our hunters and gatherers life and domesticate animals and plants. We become sedentary farmers, we establish villages, societies, and off we go in the innovation pathway that took us to the 1950 point of the Great Acceleration. So the scientific conclusion is as simple as it is dramatic. The Holocene is the only state of the planet we know for certain can support our modern world as we know it. If we take any ethical responsibility, the Holocene is our reference point. We can live outside of the Holocene. We've done it before. We've been like a few million people. But if we really want to say we have 7 billion, soon to be 10 billion co-citizens, human beings on Earth with the same ethical rights to good lives, I would argue we have ample evidence that the Holocene is our Garden of Eden. That is very good news, actually, because we know the Holocene very well. We know the composition of the ice sheets, we know the composition of all the geographic biomes, we know the cycles of nitrogen, phosphorus, carbon, water. We can actually define quite well what's the safe operating space to stay within the Holocene. That is what took us to the planetary boundaries. But that's just insight number 2. I just want to make this point because climate skeptics love to say, well, but you know, within the Holocene period, we've had so tremendous variability. It's not so stable at all. I mean, the Vikings, they grew, you know, grapes on Greenland, 1100 and 1200 because of the warm medieval period. Well, look at this. All the variations that we've had in the Holocene, definitely. We have the Little Ice Age, we have the medieval warm period, we have the Roman Empire climate optimum, has been variations within this plus minus 1 degree maximum variability on Earth. The Holocene is a very stable interglacial with its natural variability, but within which we have been able to develop. We now bump the ceiling to 1.1. We're exiting the Holocene. Insight 2. Insight 3 then is, well, how does Mother Earth respond with all these pressures? Well, we today have ample evidence, I would say again unequivocal evidence, that she does not respond as we have assumed. It's not as if things just change linearly and incrementally and thereby predictably, which, by the way, is the basis for all economic modeling, for all economic assumptions, and for every discount rate you'll ever read about. The reality is the complete reverse. The resilience of the systems, from local lakes to large West Antarctic ice shelf or the ocean conveyor belt, is that they can take pressures and stress over very long periods of time, but then abruptly shift direction, potentially even show regime shifts or state shifts when they cross certain thresholds. We have mapped this over time, and this is just a video showing a little bit of the listing of these, which our system, the tipping elements on Earth, from the permafrost that is locked into the Siberian and seabed, from the Arctic sea ice systems. You recognize even the regional weather systems like El Nino coming to the Amazon rainforest, another tipping element that stores carbon and has moisture recycling, regulating your systems. Coral reefs being a part of the ocean stability, the Southeast Asian monsoon, the jet stream, which I'll come back to. We have today quite a large advancements in Earth system understanding of the tipping elements that regulates the state of the Earth system. We communicated this to Patricia Espinosa and the United Nations Framework Convention on Climate Change for the first time in Bonn at the Climate COP meeting with the following graph. And I think this is the graph that every climate negotiator should basically hold in his or her hand. 20,000 years on the x-axis, average temperature variability on the y-axis. Here you see how we exit the last ice age and we enter the Garden of Eden period, the stable Holocene period. Here you have the Paris Agreement. Just a a quick reminder that even if we succeed with Paris, we're outside of the Holocene range. So it's not as if Paris will be a return to some kind of oasis. It will also have adaptation challenges. This is where we're heading, according to the IPCC. And you know that even if we apply the NDC, implement all the promises that nations have given, we'll probably be beyond 3 degrees Celsius warming. A place, by the way, we haven't been in for the last 5 million years. But here's the key home message. This is the latest update. No, it's not even the latest update. It's a recent update of what science says in terms of uncertainty ranges. The redder, the higher the likelihood, but the uncertainty range is the width of these columns in terms of at what temperature ranges are we at risk of crossing tipping points for these Earth system regulating tipping elements. I'm particularly focusing on this group here because you see the scientific evidence dips into Paris. It actually shows evidence that even at 2 degrees Celsius warming, we cannot exclude anymore of destabilizing the West Antarctic ice shelf, 3 to 6 meters sea level rise, destabilizing the Greenland ice sheet, 7 meters sea level rise. Look at the coral reefs. They are in the entire uncertainty range within Paris. I would call this the first planetary victim, and we have it on the table today, that even if we succeed implementing Paris, we're very likely to leave a planet for our kids and their kids without tropical coral reefs on Earth. This is a very dramatic situation, and this is where science is standing today. If you put all this together, we've entered a new geological epoch. The Holocene is our desired state, our reference point, and tipping points in nonlinear change cannot be excluded. That takes us naturally to a new framework. Because, of course, the next natural step for science is then to ask, well, if we need to stay in the Holocene and we're putting pressures up at this biophysical ceiling, what are the processes that regulate the state of the Earth system? Question one. Question two, if we can find those systems, can we scientifically quantify boundaries within which we create a safe operating space where we have a high likelihood to stay in a Holocene-like, interglacial, manageable state that can support humanity, but beyond which we risk triggering nonlinear changes and feedback that could gradually take us in the wrong direction. There you have it, the Planetary Boundary Framework. Published the first time in 2009, identifying 9 systems that we proposed to the scientific community. We were able to quantify 7 of them. We gathered 40 scientists from all different disciplines, from soil science to oceanography and climate science, defining and trying to define, and what you see here in yellow is the uncertainty range, and red is when we start moving into a pace where we cannot exclude of triggering nonlinear dynamics. They were published the first time in 2009 and then followed up in 2015 with an update. Today our conclusion is that 4 of the 9 boundaries are in a danger zone, and we need to rapidly transform ourselves back into a safe operating space. I can share with you that already in 2009, the climate boundary, one of the 9, was defined a little bit below 1.5 degrees Celsius warming. It took 10 years for the scientific community at large to actually basically corroborate what was published already in 2009 in terms of the importance of 1.5, which was not even understood in Paris. Here are the 9. I won't go through them in detail. For those of you who are interested, please read about this. But it could be just good mentioning that, of course, the boundaries include what you could call the big 3 systems, the systems that are perfectly mixed, operate at the global level, the obvious ones for everyone, the climate system, the stratospheric ozone layer that protects us against dangerous levels of UV radiation, but also the energy conveyor belt and the whole ocean system. What is perhaps a little bit more surprising is that 4 systems are the biosphere systems, the living biosphere that operates under the hood of the Earth system and regulates the ability to sequester and dampen, or that could shift gears and self-reinforce. Biodiversity, land systems, fresh water, and the 2 let's say, brother-sister cycles to the carbon cycle, namely nitrogen and phosphorus. And then we have two boundaries that are entirely alien. We call them a bit nerdly in the working teams because they're created by us humans. Novel entities, which is everything from nuclear waste to microplastics and organic pollutants, and aerosol loading, which is our interference with the optic depth of solar influx due to black carbon and larger particles of pollution, which, for example, we see today when forest fires change as temperatures and rainfall patterns regionally. Now, these have been corroborated, they've been updated, and we're aiming for next update in 2020. So all suggestions and ideas are more than welcome. The coordination from this is done at the Potsdam Institute and the Stockholm Resilience Center. This took us then to the next level of analysis, which is at what point are we at risk on the climate boundary to trigger potential cascades of change that could really move us away from a Holocene state. We published last year what we call the Earth trajectories in the Earth system, trying to ask the question that if we allow ourselves to burn fossil fuels up until 2 degrees Celsius warming, what are the risks that the biosphere might start kicking in feedback changes? Could that trigger a runaway pathway? This paper, for the first time, stipulates as a challenge for science that we cannot exclude that that is the case. In fact, our conservative assessment is that 2 degrees Celsius warming from fossil fuel burning would bump us up to 2.4 degrees Celsius warming, roughly, due to forest fire, forest dieback, due to permafrost thawing, due to changes in the biological pump in the ocean, and due to a relative decline in CO2 uptake capacity in oceans and soils. A very careful assessment, but we are afraid that that could then be linked with the tipping elements shown on the map here, and that it could lead to a cascading, which in Germany was then baptized as the High-Zeit paper, which is the risk of us triggering something that could take us inevitably in the wrong direction. So we're talking about 3 different states of the Earth system fundamentally. We have the desired interglacial, we have the glacial state that we know so well, and we haven't been beyond these 2 states actually for the past 1.1 million years. We don't really know. We're going into terra incognita by thinking of what happens moving in a direction to the right there. But it's also that colleagues at PIC, Andrei Galopolsky and colleagues, published a paper a few years back saying that probably, with a high likelihood, we have actually emitted so much greenhouse gases that we're unlikely to ever again enter an ice age, or at least not in kind of, let's say, time scales that matter for humanity. So it might be that the only remaining path is either we remain in a manageable interglacial state, or we are at risk of pushing ourselves across a threshold, which would be a warming state. Now, the good news is, and the important thing to recognize is that given that that is the risk, are we at risk of pushing ourselves towards a warmer state, that the Anthropocene is not yet that state. The Anthropocene is a pressure. We're still in the Holocene in terms of the biophysical dynamics that keeps us in an interglacial position. The Anthropocene so far is a pressure, and the big challenge and task for humanity is to avoid that the Anthropocene becomes a new state. But the Anthropocene working group that has decided that we're now in the Anthropocene is showing very worrying scenarios, which is here shown in this Anthropocene pathway, that over the next 1,000 years we could actually trigger exactly a hothouse Earth trajectory. And after the hothouse Earth paper, this paper came out by Burke et al., which I find also supports this whole, let's say, risk landscape. And what you see here, I think it's a phenomenal graph, even though it's a bit messy, but it has the last 60 million years. It's logarithmic, so you see it a bit in chunks. And further to the right, you have the yellow there is the Garden of Eden, the 10,000 years of Holocene stability. To the left there, you have the 1 million years of Milankovitch cycling between ice age and interglacial. Then you have the pathway we're following, and you see the 2100 point is 4 degrees Celsius warming. Let's assume we reach 4 degrees. I mean, the business as usual pathway. That would actually take us, there you have the 4 degrees Celsius line. You know, that would take us back to a point where we haven't been for the past 10 million years. So according to the latest paleoclimatic research, we are at risk of winding back the climate clock, not kind of 1 million years or 2 million years or 3 million years, but over 10 million years. That's just to show that in a blink of time, this is an experiment at a scale that we have never experienced before. Then came, just a few months back, this paper by Willett et al., also at PIC, which I find to be very humbling, which is that according to the latest knowledge we have and the modeling work we have, the average temperature on Earth over the past 3 million years has never exceeded 2 degrees. So again, despite all the variation, it seems like the planet has had this self-regulatory ability through biophysical, biosphere, and climate physics to stay within this very, very narrow limit cycle of -4 to 2 degrees. And then we have these indications of large changes. The changes in the AMOC, the Atlantic Meridional Ocean circulation, the jet stream transitions. You've all read about the risks that the jet stream related to changes in the pressure gradient between the Arctic and the equator, maybe the explanation of why heat waves and high precipitation pressure systems get locked into Europe, explaining potentially 2018, 2019 heat waves in Europe, but also a remarkable synchrony between California wildfires and the Japanese heat waves and floods with this bizarre behavior of the jet stream. We have more and more evidence, unfortunately, which I mentioned earlier, of rapid Antarctic melt. So there's a lot of support that this risk pattern of potentially moving out of the Holocene is real. That's why I would argue that a scientific challenge for us is really to move ahead on what I would call Earth resilience, to understand and explore more what is it that defines the ability of the Earth system to remain in a certain state. What are the feedback dynamics of all systems, the living and non-living systems, that can stay within this stabilized Earth system and avoid, that humanity and some kind of human push takes us across the threshold toward a hothouse. This was a systems diagram in this Earth Trajectories paper that tried to illustrate and challenge science on exactly this journey. And we would very much welcome, let's say, an integrated whole Earth system analysis to try and understand that we seem to be out at this slippery red slope here, where we are gradually reducing the resilience of the Holocene cup, which is in the beginning, in the furthest background here. And of course, our big task is to try and navigate back into a stabilized Earth, which is all about human and environment working together as planetary stewards. And that requires a combination of resilience thinking with sustainable development. So what does this all mean then in the last 5 minutes for the future? Well, to begin with, I do think it redefines sustainable development. I think we can no longer just think of reducing environmental impacts on economic capital, natural capital, and human capital. We now need to really consider humanity's future as prosperity and equity within a stable and resilient Earth system. We also need to understand that this is a transformative journey. The IPCC is actually quite clear. We actually need a transformation. In the 1.5 report, we've never seen this before, so clear to say that the green pathway that can take us safely back to a safe operating space is by cutting emissions by half over the next decade. This is why the German decision in the Coal Commission is so important. This is why von der Leyen's promise now to have a European Union net zero pathway for 2050 is so important. That is why Germany, as the fourth largest economy in the world, is so fundamental, because if Germany can show that you can have good prosperity, have a peaceful development while phasing out particularly coal, this would be the signal to the world to succeed. We have translated the science into carbon law, which is very simple. It is about following this pathway of reducing emissions, which translates, of course, to kind of 6–7% reductions per year, but also translates to something very simple, inspired by Gordon Moore. Gordon Moore, who stipulated in a predictive way that the speed of computers would double every 18 to 24 months, which became a self-fulfilling prophecy of innovation in industry. Well, there's a carbon law here to say that if we cut emissions by half every decade, we follow science. So it's interesting that this was published well before the IPCC report, but that is now the message from the unequivocal base of science. Cut emissions by half next decade. Now, we know that that's not enough. The brown part here is agriculture, which needs to go from source to sink. We know that not even that is enough. We need to, whether we like it or not, consider negative emission technologies at a very large scale, at a worryingly large scale, up to 20 gigatons of carbon dioxide per annum by the end of this century. And then we need to keep the resilience in the Earth system intact. The green and the blue is the ability of natural ecosystems to take up greenhouse gases. If we do all this, we have a, I'm sorry to say, 66% chance of reaching 1.5. So this is our task. It's a global sustainability transformation. It's not only about the energy transition, it is about reconnecting to the entire planet. Now, yesterday we published a paper to support this in Nature Sustainability. If you haven't seen it, it's led by Jeff Sachs. It's part of something called the Whirlwind 2050, identifying the 6 transformation areas that we believe are potentially sufficient to really deliver on all the SDGs while meeting the Paris Agreement, to try and instill some energy and injection of the potential. This is not utopia. this is definitely doable because behind all of these areas of the digital revolution, smart city planning, a food transformation, decarbonizing energy systems, we have solutions. We actually even presented solutions to the Global Climate Action Summit last year. We'll do an update in a few weeks with Christiana Figueres on our ability to cut emissions by half over the next decade in so many sectors. This is done together with Project Drawdown. There are technologies that can take us to cutting emissions by half this decade, which was the message and increasingly supported. We have so much empirical evidence here as well, and Germany is part of this, of how solar voltaics and wind is increasing from a very low number. So the last 15 years, it looks as if it's a very small part. It's only 2.8% of the energy mix. But actually, if we just continue business as usual, which is doubling every 4.5 years, we would actually have 50% of electricity in the world from solar and wind by 2030, if we just keep the current pace. So we are an exponential curve. We're following an exponential curve on so many of the, oh, thanks. Yeah, he's getting worried, which is correct. But we see so many countries today decoupling economic growth from greenhouse gas emissions, roughly 50. That's an interesting number because already Pareto, several hundred years ago, showed that if you want to cross the valley of death, when you go from startup to really penetrating a market, you need to reach roughly 20% of consumers or market penetration. And that's what we're reaching now. 50 is 25% of the number of countries. On the right hand, you have roughly 50 countries in the world have adopted a price on carbon. Everyone says it's impossible to adopt a price on carbon. 50 countries have done it. Not the right price because Sweden has the right price, of course, which is 100 euros per ton of carbon dioxide. But talk to Professor Ottmar Edenhofer. We're in very close collaboration and dialogue, actually, with the climate cabinet here in Germany to discuss how to move forward on a science-based price on carbon. We recently worked on food in the Eat Lancet Commission, trying to define with a planetary boundary framework for the first time healthy and sustainable diets to take us back to a safe operating space and increase the life expectancy of people. Our estimate is actually saving 10 million lives per year by eating healthy food, which is reducing red meat, a more mixed diet. It's not a vegetarian diet, but it's a more healthy diet. And if we apply this so-called planetary health diet within definitions of planetary boundaries, we find, and this is quite a messy graph, but this is the question, can we feed 10 billion people by 2050 if we eat healthy food produced in a sustainable way? If we go like business as usual, the top line there, it goes red everywhere, meaning that if we continue as today, we fail even on Paris just by eating in the wrong way. So even if we decarbonize the energy system, the food system on its own will make us fail Paris. But look at the furthest down here. If we invest in sustainable intensification, PROD+, if we reduce food waste by half in the middle, and if we start really adopting on a big scale healthy diets, we can go green and yellow at least. We can go back into safe space on all the planetary boundaries studied here, which is water, biodiversity, nitrogen, phosphorus, and climate. So it is not utopia. We see that prosperity and equity is something that can be done. We have a challenge here. This paper was fantastic, I would argue, from colleagues at Leeds University, showing that countries in the world, in all the circles, these are all the countries in the world, and on the x-axis is the number of planetary boundaries that they are transgressing. So the further to the right, the worse you are on sustainability. But on the y-axis, you have the number of really good social indicators that are met. So the further up you are on the y-axis, the better is the life satisfaction, the better is the GDP, the better is equity levels. And what you see is, up to the right-hand corner, you have Germany, Sweden, the OECD bloc. So we have to admit that still, 2019, we are delivering, those countries who are succeeding are delivering on human well-being at the expense of the planet. We're still in that mode that took us into the Anthropocene. Nobody is where we want to be. Nobody is actually succeeding within planetary boundaries. So, I mean, the challenge is enormous. The SDGs provides us the framework. I would argue that it should look like this. It's not a Swedish smorgasbord where you can just pick your little goodies and choose your favorite goals. We have to understand that there are 4 non-negotiable goals. Goal 6, 13, 14, 15. Freshwater, biodiversity, oceans, and climate that provide scientifically based planetary boundaries within which we can have aspirational goals for humanity. I think that's the new paradigm we need. We're working on this. Right as we speak, we have the so-called Earth targets for business today, which is a global commons alliance with the Global Environment Facility and the World Economic Forum and others, trying to define scientifically based targets for businesses and cities in the world based on science. We're now launching an Earth Commission, which is like an IPCC for the planet, to try and define quantitative scientific targets for a safe space to provide scientifically based targets, not only for climate, because as you may know, over 700 companies are today adopting scientifically based targets for climate. Carbon budgets, for example. Now is the time to go for biodiversity, for water, for nitrogen, for phosphorus, for all the systems regulating the planet. This is ongoing as we speak with a large support and momentum. It's really exciting. The World Business Council for Sustainable Development is very, very deeply engaged in this. We have the World in 2050 that I've been reporting before, coordinated by IIASA, the International Institute for Systems Analysis, with a large support from the Sustainable Development Solutions Network, exploring transformation pathways to meet the SDGs within planetary boundaries. So there is work going on, and I think that to me, the final closing message I'd like to leave with you is I think this is the way to think of the paradigm, that yes, it is about the SDGs within a stable and resilient Earth system. So on that question, whether sustainable development goals within planetary boundaries is utopia or panacea, I think it's neither utopia or panacea. I think it's a necessity, and I think it's an opportunity. And I think there's so much evidence in support of that. The drama right now is not that there are people questioning this and denying it. The drama now, there's so many people sitting on the side, not moving, sitting on the side quite passively. So on my door, every morning when I go into my office in the Karl Schwarzschild's office at the Potsdam Institute, this faces me each morning. And I think it's quite healthy to be aware of this, that the world will not be destroyed by those who do evil, but those really who watch them without doing anything. I think that's the point we've reached today. We need to start really moving at a much wider scale. And that is why this dialogue here, and inspired by the great champion of them all, Professor Alexander von Humboldt, is so exciting. Thank you very much.
I knew it would be a great talk, and I knew that the room would be full. I didn't knew that the talk was so great. Thank you very much. Even though we are limited in time, today we have been deciding that we would offer the audience a few questions, if there are, things that you would want to discuss with Johan Rockström. Now there is the option. We have a microphone in the audience, and someone will rush to you with this microphone. It's first one in the back, and then we have a second one down here. Please say your name and keep your question as short as appropriate.
Well, Felix Eckert, lawyer, philosopher, sociologist, professor from Leipzig. Johan, thanks a lot for the very inspiring talk. Just one question. I really try to keep it short. As you, of course, know, the question of targets is a question to normative disciplines such as law, political science, and ethics. And for me, as a normative scientist, I strongly feel that you're even a bit too weak about the target, because the Article 2, paragraph 1 of the Paris Agreement, in my opinion, in my legal interpretation, doesn't offer a Paris space from 1.5 to 2 degrees Celsius. It says well below 2 degrees Celsius, and there's also an obligation to try to meet a 1.5 degrees Celsius target. And from the legal point of view, given that 1.5 is obligatory, it's not enough to meet it with a probability of, let's say, 50 or 66%, like in the IPCC scenarios. So this means that saying like the IPCC special report on 1.5 degrees, we have time until 2050 to meet a zero line is probably even too optimistic. So to be a bit more provocative, why didn't you talk about options other than technological options? Because you mentioned, like the IPCC, the technological perspectives, you mentioned geoengineering, which is a highly problematic option from the legal and ethical point of view. Why didn't you talk about frugality?
Yeah, no, thanks. I very much agree with your assessment here, and thanks for that reminder. It's really important that we are aware that Paris is a legally binding agreement. It's legally binding in its overall framework. It's often misunderstood as being a voluntary, but it's only voluntary in the content of the national plans, but it is legally binding in staying well below 2 and aiming for 1.5. So I fully agree with you here. And when it comes to the solution space, no, you're right. I mean, there's a much broader agenda here, both legal and behavioral change and equity and also technology. So this is a broad spectrum. So I'm totally with you here. I would argue, though, that we are in such a dire, we're so pressed on time in terms of what we need to achieve at such a large scale in just 10 years that top-down measures will have to be the dominant path. I mean, there's no way, I would argue, for Germany to stay on, preferably surpass its commitments from the Coal Commission without having very strong political leadership from above. But of course, it requires very strong social and legal support within society as well.
My name is Sigrid Rösner. I'm a neighbor from the Telegraph Hill, from the Geo Research Center in Potsdam, and I'm a geographer. Thank you very, very much for your very inspiring talk. Just to be short, however, one thing I have been thinking the whole time, how privileged are we that we are sitting here and discussing this while a significant part of our human fellows have no space even to move because they are victims of terrorism, they are victims of war. Everything between Syria and Afghanistan is a war zone. We have been watching this for 20 years now and more. And I'm wondering, I'm thinking humanity will extinct itself if humanity doesn't get a grip on that and the global concerned part of the population we are part of. So I'm interested in how do you deal with that conflict? I mean, I'm sure you're very aware of that, having been in Africa and elsewhere. What is your ideas on how can we move forward or help move forward?
Yeah, no. I mean, this is, I think, perhaps my not so so satisfying answer would be that, I mean, you're absolutely right, and it's not only terrorism and conflict that is a challenge in the world. It continues to be absolute poverty. It continues to be harassment. It continues to be a number of big challenges. We have basic health care. I mean, poor quality water kills more people than climate change still, so that is correct. But I get very frustrated when people like Björn Lomborg, for example, uses that argument to say we have so many problems out there, so it's not worth doing anything about climate change. Because if you do an economic assessment, it's better to put the money on mosquito nets than to put it on mitigation. I think we have to keep many balls in the air at the same time. I think we simply have to understand that these are kind of the social, ecological, geological, or geopolitical reality we live in. And more, as a final comment, more and more we see interconnections between these. We see that conflicts are related also to health and climate change, water scarcity, food security. This is very difficult to put the scientific evidence fully behind, but I think we can today say enough that we cannot untangle these, we cannot keep them separate. So we have to bring it in. We were very impressed by the fact that the German Chancellor and the Foreign Office here, as a part of the German membership now of the UN Security Council, brought up climate and conflict as one of the priority areas and had a conference here in Berlin, actually, some half-year back, that we were kind of scientifically supporting. So I fully support you.
We have two final questions. Make it short, please.
Hi, thanks for your talk. I am a political theorist, and I was wondering about how to persuade people about this pressing reality in a world where parliamentary activity can be suspended in the name of the people, as it's happening now in Great Britain. So my question concerns the role of uncertainty. How do we communicate uncertainty? How do we explain uncertainty about future projections for the Earth system to people who are skeptical about the epistemology behind it, because, of course, current observations are much more precise than future projections. And that can create an uneasiness in some people about big transformation taking place on account of that ground. So that would be mine.
Yeah. No, that's a great question. And I'm not the right person to try and give a qualified answer. I think you have many more people in this room who would give you ideas, because you're putting your finger on kind of the part of the Holy Grail here. How can we communicate, and how can we really get a new value base or a new paradigm to start really moving? My only reflection at this juncture is the following, which also may come as a little bit of a different tack on this, which is that, you know, when you look at populations in general, what we find increasingly is that you always have one fringe at the furthest extreme end of the population, which are the denialists and the die-hard skeptics that I think we've spent too much time with and should never more spend any time with. I mean, we should just leave them there. There's always that they will always exist, and it's pointless to fight. Then you have the other end, which are the really super engaged, you know, environmental movement. They play such an important role to always be there at the front line. But they tend to never reach more than 15%. It's like there's like a little glass ceiling there of how many. And I think large part is that is because the story generally goes that we want to go so deep back into nature that requires a sacrifice. There's some form of sacrifice related to that story. And then you have the indifferent majority in the middle who don't care that much, and we never listen to the scientific message, and they're certainly not in this room. How do we get that majority on board? And I think that the only way to get them on board in 10 years' time is that they get on board without not even realizing it. You know, they just surf along without knowing what happened, basically. That perhaps indifference is our best friend. You know, that basically just the cheapest tomato is the sustainable one with zero carbon. You just buy it because it's the best one. The reason why Tesla is succeeding is that it happened to be not only an electric car, it's also a better car. It's more attractive car. I think we have to make the sustainability transformation. The story should not be so much about uncertainty and risk. The story should be more about surf along the great opportunity. And I think that the time Germany can make that case, that's why Germany is so important, because if Germany can show the world that we can be best in the world on competitiveness for our industry while being fossil fuel free, I can assure you that in Beijing that will have some shakeup. So I think it's a question of, but I'm the wrong person for that. You saw my lecture, it's not the right lecture.
So we have the last question over here, please.
No, I'm only wondering the fires in Brazil and the Amazonian, and when I see the graphic, that no population, I don't know if I have understand properly that have made it in a sustainable ways, and there is over 1 million people have been displaced on fire in the Amazon today, and this means I think so. There might have been, and there have been, and then we are maybe not looking properly of who might have, and maybe is able to showing a path of how we could have a sustainability way of living, but I have not seen in your graphic on the left side of your diagram, or I might have not being able to recognize that, yes, there are people on planet Earth today who knows how to live.
Yeah, so Eric Lambin is here, who's the scientific expert here on the stability of the rainforest systems, but it's not, the Amazon rainforest is not in that furthest left range of tipping points already at 1 to 2 degrees Celsius warm because of the scientific uncertainty, actually. We don't know really at what temperatures the whole system would be destabilized. And one reason for that is the complexity of destabilizing any biome, but certainly the rainforest systems, because it's not only temperature, it's also about the way and pace of deforestation. And as you may know, there's so much papers out there ranging from you lose 20% of the rainforest and it might topple over all the way down to 40%, and it's unclear to what extent it is temperature related and deforestation related. So this is something that I think we still need much more precision on, and the big dark horse are the forest fires, actually. I mean, that is one of the abrupt changes that we don't have a full handle on. But Eric, yeah, you might want to fill in here. don't know if you're still in the room, but anyway, this is a big area of need for rapid research on.
Thank you very much, Johan Rockström at the keynote.
Yeah, thank you.